Salamat Sesbia. Well, that's the way we say hello in Kazakhstan. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mensuration. Now, children, in this lecture, we are going to look up what two-dimensional and three-dimensional mensuration are. We'll be looking up the different formulae which can be used as our need be. Then we will be looking up pouring a liquid from a cylindrical container to another cuboidal tank, and then when there is a rise in the level of the liquid, we will be talking about how much time has elapsed in doing that, and thus we will get a relation and find the time out. So all of these concepts we are going to discuss in this lecture, but before we get started, I have a fascinating information for you people. That is that we are going to have this class on mensuration here at this lovely place. So imagine that you are skiing on the ice cap peaks, or moving on cable cars which take you to Meadow Gorge, where the world's highest rink is located. It is here that you will get to see some professional ice skating or some ice hockey matches which are being played. Now, when you go to this place, make sure to have gent, which is a famous sweet delicacy, very mouth-watering, I can tell you. And then make sure to tell all the people of Kazakhstan that you get to meet Salamat Sesbia. In this note, children, I'm again going to say Salamat Sesbia, but at this time it is to mensuration. So like I told you people, when we talk about mensuration, it can be two-dimensional or it can even be three-dimensional. Now, if you talk about two-dimensional mensuration, we talk about rectangles, right? As you know, that rectangle is such a solid which does not have any height. So if we talk about, say, something like this, this is a rectangle, and as you can see that it is just on a surface, right? Thus this is two-dimensional. That means it has some length along the x-axis, it has some length along the y-axis, and thus it is on a plane or is on a surface. Similarly, we can even be talking about a circle, right? A circle also is two-dimensional, right? So if, say, we talk about a circle may look, say, something like this. So as you see, this is also in a plane. That means it is within a surface which has some x-axis, which has some y-axis, right? So when we talk about the mensuration of such sort of figures, we just talk about their perimeter, that is the length of their boundaries, right? Or we talk about the areas, that is the amount of space that they are taking in the two-dimensional space, right? Now after this, we also talk about some three-dimensional entities, like we talk about a cuboid. So when, children, we talk about a cuboid can probably look something like this. It is, if you try imagining, something like a matchbox or probably your school duster. So let us now consider we have such a sort of an entity, and here, children, we have this as a cuboid, you can say, but before this is made into a cuboid, obviously these corners have to be joined. So let's say now we have the join of these two corners, and similarly we will have the join of another two corners like this, and then we will have the join of another two corners like this, which will take us to the last joining process. And here, thus, we have the last join also formed. So now I'm sure you're easily able to imagine that this is a cuboid, or something like the school duster, or probably a matchbox, or probably any other box, right, which is a rectangle which has been given some height. So remember, children, whenever we talk about such a sort of a solid, there is some length, there is some breadth, and obviously there is some height, right? Breadth is along the y-axis of, say, a surface. That surface can be the surface of your table. So if you consider your table, and if you consider the bottom left corner, you can consider that to be the origin, right? On the right hand side will be the positive direction of the x-axis, on the left negative direction. Above will be the positive direction of the y-axis, below negative. Then if you talk about along the height, that is above the surface of the table, you will have your z-axis positive, below will be z-axis negative. So as this exists in 3 dimensions, so this is such a solid whose volume can be found out, right? So here children, we are talking about a cuboid, right? That is, it's a rectangle which has been given some height, and when we talk about the volume of a cuboid, that is actually length into breadth into height, right? You can just imagine it this way, that you have some rectangle which does not have any height, right? And further above it is another rectangle, right, which again has negligible height. And if this is done for L number of time, or sorry, H number of times, which is the height, right, you will get the volume of this cuboid to be L into B, which was the area of the rectangle, multiplied with some H number of rectangles, right? So this is how you find out the volume of a cuboid. Next, now we'll be talking about another solid that we require in this question. That is, if say we talk about a cylinder, it is again something which you have seen a lot in your everyday life. If you talk about a piece of chalk, that is a cylinder, right? Because there is a circular cross section at the bottom as well as at the top. And if you talk about the portion which is within, is actually long, right? And you can actually move about that length, and as such you call it to be the curved surface, right? And the top and the bottom, they are flat, but they are both circles, right? So here children, we are trying to consider that there is a cylinder, and like I told you, at this time you can just imagine that there is a glass chalk that is in front of you. And here children, at the cross section, we will also be having a circle which can be made, say, something like this. So here, say, we can talk about this to be that cross section, and this thus shows you that probably this is a pipe. And now we are not going to make the circular end of the other side, because this can probably continue for a long length, right? So this is one such cylinder, right? And if you talk about a pipe normally is also a cylinder, a pipe with which you water in the evening your hedges or probably different plants. They are actually cylindrical pieces of solid through which, when you open the tap, water comes out at a specific speed, and then you are able to water the different plants. So this is one such cylinder, right? And as you know that here we have the circular cross section all through. So if the radius of cross section is r, right, we can talk about the volume of this cylinder to be the area of cross section of one of the ends multiplied with the length for which it continues. For example, let us consider that here we have the length of this cylindrical container up to h, right? So pi r square is the area of one of the ends, and as it continues up to h height, so it being multiplied by h will give you the volume of the cylinder, which is pi r square h, right? So here children, we have a pipe, we have a cuboid. Now children, I like you people to give you the sum, where first I like you people to quickly give it a try. I'll give you a few seconds for trial, and after that I will be discussing the sum with you people. Right, so children, in this question we've been given water is flowing out at the rate of 15 km per hour through a pipe. So there is a pipe. Suppose if we make a figure, I am sure you'll be able to understand much more. So let's say now that we have this cylindrical pipe like earlier. So this, say, is the length of the pipe, right? And then we will make another piece, its parallel side, and then we have the circular cross section, so that too we can have here. Right, so this is probably that cylinder which at this time we are talking about, right? And here, children, what we are going to do is we will consider that there is some water which is coming out of the cylinder, right? And as we've not been given, so we will consider that the water which is coming out of it is actually coming out of the full cross section of the pipe, right? Okay, the rate of the fall of water has been given to us. That means the length of water which is falling off in a single second is actually the rate at which the water is coming out. Just try imagining the cross section. From the cross section, you have from all portions water coming out. So if you talk about the speed, it is actually the length of water in the pipe which is fallen off. So that will give you the speed of water which is coming out of the pipe, and that is why it is in kilometer per hour. That means if you talk about the unit, it is just a unit of length. If it would have been the volume that was being talked about, so you would have talked about kilometer cube per hour. Did you understand, Ruhi? Sure. Okay, so when we talk about the speed of water which is coming out, it is actually the length or the height of water which is coming out in a single hour. And here, children, it has been given to you to be 15, and it is in kilometer per hour. Now if you talk about kilometer and hour, they are bigger units, and here we'll try and prefer units which are smaller, like meter, centimeter, etc. So children, here what we do is, now further after this we will now be talking about here the length, right? Fallen in 1 kilometer, or rather 1 hour. Length fallen, right? We will just talk about that, and now we will convert it. That is 15 kilometer per hour. Now as I told you, we are going to convert this to meter per second. So this can be written as 15 into, as 1 kilometer is equal to 1000 meters, so into 1000, and this is going to be divided by 3600 seconds, as 1 hour has 60 minutes and 1 minute has 60 seconds. So 60 into 60, that is 3600. Now children, as you know, both of these zeros which are powers of 10 will get cancelled from the numerator and from the denominator, and then we will have 2 5s is 10 and 2 18s is 36, and then further we have both of these which have the common factor 3 getting cancelled. So we have 3 6 is 18 and 3 5s is 15. As such, here 25 upon 6 meter per second will become the length of water which is falling off from the pipe. Now further, here we've been given through a pipe of diameter 14 centimeter. So if you talk about the radius of this pipe, the radius of the pipe has been given to you to be 7, which will be half the diameter, right? So this is our value. So this of the pipe, which is actually cylindrical, is 7 centimeters. Now look up here, children, we have been given one length in centimeters. So as this is a smaller unit in comparison to meter, so obviously you will convert the unit which is in meter also in terms of centimeter. So as 1 meter is equal to 100 centimeters, so this is going to become equal to 25 into 100, which is divided by 6 now in centimeter per second, right? So we have all the things ready for a cylinder. Now let's look up what's happening. Into a cuboidal pond. So there is a cuboidal pond in which this water is falling off. So now let's quickly make that cuboidal pond. So let us say that cuboidal pond, say, looks something like this, right? And at the moment we are going to have its top removed, as the water is to fall inside, right? So this, say, is that cuboidal tank in which the water is falling off, right? And let us say some water has fallen off and this much amount of water has already risen in it, right? So this actually will give you the rise in the level of water, right? So as the water percolates from the pipe into this container in which it accumulates, gradually the level of water will increase, and at a time when it is looked up, that will be the rise in the level or rise in the height of water in a specific period of time. And here we're going to talk about that. We will be discussing that just now. Now, water, when it has fallen into this container, as you know that a liquid always takes up the shape of the container in which it is kept. As such, this water which has fallen into this cuboid will actually pick up a cuboid shape, right? So the shape of the water is going to be cuboidal, as water, being a liquid, picks up the shape of the container in which it is kept. Now, in order to find out the volume of this cuboid, again you will use the same formula, as the length will be the length of the container, the breadth will be the breadth of the container, and the height will be the rise in the level of water when the water has fallen from the pipe to the cuboid. So this will give you the volume of the cuboidal water, right, which has fallen in a specific period of time. Okay, so here we've been given the dimensions, which is 50 meters long and 44 meters broad. In what time will the level of water in the pond rise by 21 centimeters? So we've also been given the rise in the level of water, and rise in the level of water, let's say it reaches up to here, right, has been given to you to be 21 centimeters, and this we are going to use in finding out the volume of water which is there in the cuboid. So we will say that volume of water in the cuboid will become equal to length into breadth into height, and length has been provided to you to be 50, and you will multiply it by 100 because you've got to convert meters to centimeters, and further we will multiply this with the breadth, which is 44, and again we will multiply this with 100 as it was in meters and we require to convert this to centimeters, and then we will multiply it with the height, which is 21 centimeters, that's why into 21. So this, children, will become the volume of the water which has accumulated when 21 centimeter is the rise in the level of water. Okay, now we've got to find out the time in which all of this happened. So for that we will call in unitary method. Now we know here that the volume of water which has fallen in a single second from the pipe will be found out by the cylindrical water which has fallen in a single second, right? So now we can talk about that. So we will say that volume of water fallen, and which obviously is what is cylindrical, right, will become obviously equal to pi r square h. And here, children, we will substitute the values. So we have here pi, which obviously can be written as 22 upon 7 into r square, as r was 7, remember the diameter was given to you as 14, so you will have into r, and further you will multiply this with the height, which is actually the length of water which has fallen off in a single second. And remember, we talked about the speed, that was the length of water which has fallen in a single second, and that came out to be 25 into 100 divided by 6. So into 25 into 100 divided by 6, this in centimeter cube, right, per second is the amount of water which has fallen off from the pipe in 1 second. So now, children, we will be writing, using this statement, the first statement of unitary method. As you require the time, you will keep the quantity which requires to be found out on the right hand side. So as such, here you will say that this much amount of water, that is 22 upon 7 into 7 into 7, into 25 into 100 divided by 6 centimeter cube falls in 1 second, right? And now the amount of water which requires to fall is actually the amount of cuboidal water which actually has got accumulated here when the rise in the level of water is 21 centimeters, right? So here thus we will write this volume that we found out, that is 15 to 100 into 44 into 121, right? So now we will say for obviously 1, right? As in unitary method, first we talk about some physical quantity related with another physical quantity, then we talk about one physical quantity related with how many, and then we talk about some more or probably some less physical quantities. They'll be equal to how many of the second physical quantities. So here children, we'll be talking about 1, so we will say that 1 centimeter cube falls in right upon left, that will be 1 divided by 22 upon 7 into 7 into 7 into 25 into 100 divided by 6. Now further here children, what will happen is we will have these numbers reciprocating to the numerator, the numbers which are in the denominator, so that will then become equal to 7 into 6, which will be the numerator, and in the denominator we have 22 into 7 into 7 into 25 into 100, right? So this is the amount of water which has fallen off, 1 centimeter cube has fallen off in this much amount of seconds, right? Now children, we'll talk about the amount which is that of the cuboidal water. So we will say that therefore 50 into 100 into 44 into 100 into 21, right, centimeter cube will fall in how many seconds? That will be now the one which is of 1, that is 7 into 6 divided by 22 into 7 into 7 into 25 into 100, right, which will be multiplied with the new quantity, that is 50 into 100 into 44 into 100 into 21. Now here children, there are certain common factors which will get cancelled, like we have 100 and 100 which will get cancelled, right? We have 25 which will get cancelled with 52 times, and then we have 22 which will get cancelled with 44 2 times, right? Then we have one power of 7 which will get cancelled, and another power of 7 which will get cancelled with 21 3 times, and thus there is nothing which is there in the denominator. And in the numerator we have here 6 into 2 which is 12, 12 into 2 which is 24, and then we have 24 into 3 which is 72, so we have 7,200 seconds, right? Now as this is 7,200 seconds, thus very easily you can convert that to hours by dividing it by 3600. So 7200 upon 3600 hour is what you will have as an answer, as this was a large number, so it could easily be converted in hours. That is why we are doing this. So here 2 bars of 10 will get cancelled from the numerator and from the denominator, and 36 will cancel 72 2 times. As such, this is 2-hour period in which the water level rises by 21 centimeter. So children, all of this I'll just quickly explain so that if there is any confusion, all of that gets cleared. In the question you've been given here that there is water, right, which is flowing at the rate of 15 kilometer per hour. So there is this pipe children through which water is flowing at the rate of 15 kilometer per hour. But if you talk about this unit, this is a very large unit, and the unit of the other lengths which we've been given in the question are actually smaller units. So that's why we will convert this in terms of meter per second, and as the need is in this question to convert in terms of centimeters, we will further convert it to centimeters even, because that is a smaller unit, right? Okay, So here children, we will first say that the length of water which falls off in a single hour is actually 15, because if you talk about the water flowing at some rate, obviously the cross section of the pipe, which is circular, right, that with some length which is falling off in a single hour, say, or probably in a single second, is the volume which is fallen off. So actually, what's it that is giving you the speed? It is the length of the water which is coming ahead, isn't it? So if you consider the cross section, so the length of water which has come out, right, that with respect to some unit of time will give you the speed. So here, as it is 15 kilometers of water which is falling off in a single hour, so that's why the speed or the length of water which is falling off in a single second is a single hour is 15 kilometers, right? Now, like I told you, this is a unit which requires to be converted in terms of a smaller unit. So we will convert this to meter per second by converting the kilometers to meters. 1 kilometer is equal to 1000 meters, and we'll convert the hours to seconds. That is, 1 hour is equal to 3600 seconds, as 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. Now 0 0 0 0 will get cancelled from the numerator and from the denominator, as there are 2 powers of 10, and then with 2 as the common factor, 2 5s is 10 and 2 18s is 36. We have 5 upon 18 here. So with the common factor 3 now we can cancel. So 3 6 is 18 and 3 5s is 15. So 25 upon 6 meter per second is going to become the length of water which has fallen off from the pipe in a single second. Now children, here further we are told that the diameter is 14 centimeter, right? So one of the units is a smaller unit. So as such, what we will do is we will further convert this meter to centimeter, as 1 meter is equal to 100 centimeter. So as such, we will have 25 into 100 upon 6 centimeter per second to be the length of water which has fallen off from the pipe in a single second. Now children, after this, we have been given that this water is actually falling into a cuboid pond which has length of 50 meter and has a breadth of 44 meter, right? So here we make a cuboid tank in which the water is falling, right? The length and the breadth have been given to you, but as they are in meters, they require to be converted to centimeters by multiplying each of the length and the breadth by 100. Okay, in what time will the level of water in the pond rise by 21 centimeter? Okay, so here first, if you talk about the volume of the cuboid shaped water which has got accumulated when the cylindrical shaped water falled off, right, into this cuboid tank. So we can very easily find out this volume of water which has got accumulated, as we have the length, we have the breadth, and we also have the height, right? And since the volume of a cuboid, right, is given by this formula which we've just studied, that is length to be multiplied by the breadth to be further multiplied by the height. So we'll be using this formula to find out the volume of water which has got accumulated, but actually will be cuboid shaped water, as a liquid picks up the shape of the container in which it is kept. Okay, so 50 into 100, because this is getting converted to centimeters, 44 into 100, as again this is also getting converted to centimeters, further multiplied by 21, which was the rise in the level of water. Now for the children, here what we do is, when we talk about the volume of water which is cylindrical, which has fallen, right, will obviously be using the formula of a cylinder, that is pi r square h is the formula of volume of a cylinder. And if you watch carefully here, the water which is falling off from the cylinder is actually cylindrical in shape, because again water will pick up the shape of the container in which it is kept. So the cylindrical water which falls off in a single second will be given by pi r square h. So here we calculated pi 22 upon 7, as the diameter had been given to you to be 14, so obviously the radius is 7, so into 7, that is r square, into the length which has fallen off in a single second, that we calculated to 25 into 100 divided by 6, right? So this many centimeter cube in a single second. Okay, now children, as we require to find out the time, right, we will find out the time by applying unitary method here, and in unitary method whatever is unknown, that is kept on the right hand side, right, in the statement. So here, as such, the above statement is going to be framed like this. We will say that 22 upon 7 into 7 into 7 into 25 into 100 upon 6 centimeter cube falls in 1 second. So here on the left hand side we have written the volume which is fallen off, and on the right hand side we have written the time in which it has fallen off. As further in times to come, we require to find out the time in which the level of water rose by 21 centimeter, right? So now, as in unitary method, we find for 1, so we will say for 1 centimeter cube it will fall in how much time? That will be right upon left. So we have 1 divided by 22 upon 7 into 7 into 7 into 25 into 100 divided by 6. Now children, as the denominators of the denominators on reciprocation, will go over to the numerator. So we have 7 into 6 in the numerator, and in the denominator all of these terms get copied. That is 22 into 7 into 7 into 25 into 100. Now further here, this many seconds is going to be required, which obviously is fractional. Now further, you require it for the cuboidal shaped water which has got accumulated in the cuboid pond. So as such, for that much amount of volume, how much time will be taken? That will be the one which is for 1 centimeter cube, which is going to be multiplied by the new quantity, that is so much centimeter cube. So for 1 it was 7 into 6 divided by 22 into 7 into 7, right? 22 into 7 into 7 into 25 into 100, and further we multiply it with the new quantity, that is 50 into 100 into 44 into 100 multiplied by 21. Now for the children here, 100 gets cancelled, 25 cancels 52 times, and then we have 7 which cancels 7, and another 7 which cancels 21 3 times, and then 22 cancels 44 2 times. This, you see, is the benefit of not calculating earlier. There were some common factors, I could have cancelled them off, but it's best to keep it up to the last step where many common factors get cancelled. As such, much calculation is from which you can save yourself. Do remember this, that always calculate unless and until you require to find out an answer. If you don't require to find an answer, just keep it as it is. You will get to see that there will be many constants which will get cancelled. Right. So next now children, what we do here is we now cancel off as we are. So in the denominator we are now left out with nothing. But if we talk about the numerator, it is 6 2s is 12, 12 2s is 24, and 24 3s is 72, and 2 zeros. So 7200 is actually the number of seconds which the pipe has taken to fill the tank up to a depth of 21 centimeter. Now for the children, as this is a lot of seconds, we can convert this to hours by dividing it by 3600. So 3600 cancels 7200 2 times. As such, 2 hours is the amount of time in which the water is poured in from the pipe to the cuboidal tank. Now children, if you've seen the sum carefully, there is another second part to this question. So now we come to that second part. Here we have what should be the speed of water if the rise in the water level is to be achieved in 1 hour. Okay, so in this question now you have to talk about the speed of water which is coming out of the pipe, now a different value, if in place of 2 hours the water gets accumulated in a single hour. So directly looking at the question, you can't say that this is going to be done in 1 hour by increasing the speed of water which is coming out, right? As it is not directly proportional just to the length of the wire which is falling off. It is also dependent upon the area of cross section. It is also dependent upon the length and the breadth, right? So we will calculate this. So the volume of water which is required is actually that we calculated earlier. So we will say that volume accumulated is what we know, that is 50 into 100 multiplied with 44 into 100 further multiplied by 21 centimeters, right? So this in centimeter cube is actually the volume of the water, which still requires to be accumulated, but this has to happen in 1 hour, right? Now children, we do not know the speed of the water's delivery, or in other words, we do not know what is the length of water which falls off in a single second. As such, here we will say that volume of water from eliminated from the pipe will then be given by the area of cross section, which is pi r square, and you will multiply it with the length which has fallen in a single second, and we will assume it to be some x. So what is x here? X is length of water fallen in 1 second. Okay, so here children, next what we do now is we will calculate this, and here we have it to be pi, which is 22 upon 7, and then it is going to be multiplied with the radius square, that is 7 into 7, and further it will get multiplied with x, which is the length of water which has fallen off in a single second. Okay, so this is the volume of water which has fallen off in a single second. Remember children, here in this we have to find out the speed, right? So if you talk about this volume that you've got, this is actually the volume of water which has fallen off in a single second. Now you actually require the amount of volume which has fallen off in a single hour, right? So as such, you require to multiply this with 60 into 60, right? So that will then be in seconds the amount of time which is required, right, to have this much amount of water accumulated in the cuboid. So now you will say that this is in 1 second, right? Therefore water, or here you can say that water, just a second, you will say that water poured in 1 second is equal to 22 upon 7 into 7 into 7 into x as above. As here we are talking about x to be the length of water fallen in 1 second, right? So thus water poured in 1 second is this much, and as this process is being done for an hour, so we will say that water poured in 1 hour will become equal to, obviously this converted to 60 into 60 into seconds, that is water poured in 60 into 60 seconds, and that will become equal to this 22 upon 7 further multiplied by 7 further multiplied by 7 further multiplied by x, also multiplied with 3600, as all of this is being talked about in seconds, right? So this is the amount of water in centimeter cube, right, which has actually fallen off from the cylindrical pipe in an hour, right? Okay, so now what we do is we will now be talking about equating both of these volumes. So here you will say now, in fact you already said this, I think, volume of water, no, that's not been said, we will say this now. So since volume of water poured from pipe obviously is equal to volume of water accumulated. right? Obviously in the cuboid. Since both of these volumes are equal, so as such now we can equate it. If you talk about the volume of the water which has been poured, so that is 22 upon 7 into 7 into 7, right, into x, which is the length of water fallen off in a single second, right? And further we multiply it with 3600, which is the total period of time, that is an hour written in terms of seconds. Now on the right hand side, children, we will now write the dimensions of the cuboid shaped water. That is, we had 50 as the length, and since it was in meters, we multiplied by 100 so that it can be in centimeters. Then further we talk about 44, that to be the breadth. Again, it is in meters. We will convert this to seconds, to centimeters, and then further we will multiply it with 21, which is actually the height of the water risen. Now this will thus give us a relation between the rise of water and the time in which the rise of water has happened, as I discussed initially, right? So here you find that if you talk about x is what? X is the length of water which has fallen in a single second. That means it is what? It is actually the speed with which the water is coming out of the pipe, and this is what has been asked to you in the question. What should be the speed of water, right? That means the speed of water or the length of water which is coming out of the pipe is something that is required. Now children, further we are going to calculate this. So we find that there are some quantities which are on either side of the equation which can be very easily cancelled off. So here we have 7, which will get cancelled with 7. The other 7 will get cancelled with 21 3 times. And then we will have 2 powers of 10 getting cancelled with 2 powers of 10 in 100. Further here we are left out with 22, which will cancel 44 2 times, and thus we can now write the value of x, right? And thus we will have our x to be equal to, on the left hand side we are left out with nothing except 36, right? So here we can further even simplify this 36 as 3 12s is 36. And then further, I don't think any simplification is possible except if we talk about 4. So we'll do it just now. So at this time now, to simplify this further, we will now have 50, which is multiplied with 100, which is further multiplied with 2, which is further multiplied with nothing. And in the denominator, we now have here 12, which is left over from the left hand side, and I think that is all right. 50 into 100 into 2. Okay, now children, here we get to see that we can very easily cancel off 12 with 2. 2 6 is 12, and then further we can cancel off again 1 part of 2, so that will then become equal to 2 3s is 6 and 2 25s is 100. So that thus gives us 2500 upon 3, right? And that is centimeters per second. Now children, obviously this being an improper fraction can be converted to a mixed fraction. So now we will say 3 8s is 24, 1 remainder, so that becomes 10. So 3 3s is 9, and then further again 1 remainder, so 3 3s is 9, again 1 remainder, so 1 upon 3 or 0.33 centimeter per second will become the speed of water which is coming out of the pipe in 1 second, right? So 833, 1 upon 3 centimeters of water is coming out of the pipe in 1 second, so that this task of filling up the cuboid up to a height of 21 centimeters can be done in an hour. As you see, it is coming to be a little different, right? We are not seeing that the speed has just got doubled, right? So it is different. So that's why make sure when a question is given to you, don't have some preconceived notion and do the sum thinking not about the maths, but thinking that what you've thought, rather half thought, is correct. So make sure you think it out properly and if it is suggested by the rules of maths, then go ahead with it, otherwise not, right? Okay, so now children, this becomes the other answer that we were required to find out. Now I will quickly tell you the second part of the question. Now in the second part of the question, children, we've been given here that we have to find out the speed of water coming out of the pipe if the task of filling up to 21 centimeter of the cuboidal tank is to be done in an hour. So here children, when the water is to come out, we know that the cross section will remain to be the same, that is the radius of cross section will be 7, right? So pi into 7 square multiplied with some length which will fall off in a single second, right? Then if we multiply it by 60, that will be the total amount of water which will fall off in an hour, and that should match the volume of the water which has got accumulated in the cuboidal tank, such that the height of water or the rise in the level of water be 21 centimeter, right? So this is what we've used as a concept. So the first thing is we have assumed that we have the speed of water to be, say, some x centimeters per second, right? So the water which has got accumulated in the tank, the cuboidal tank, is actually 50 into 100 its length, into 44 into 100 its breadth, into 21. Moreover, as 50 and 44 were in meter, they've been converted into centimeters. So this is so much centimeter cube of water, right, which is accumulated. Now water which is coming out of the pipe in 1 second, right, if we consider x to be the length of water which is fallen in a single second in centimeters, then pi r square, which is the area of cross section, multiplied with the length which is fallen off, will give us the volume of water which is fallen off in a single second. Now here, thus keeping the values, we have 22 upon 7 into 7 as the diameter of cross section was 14, so the radius will become 7 into 7 into 7 into x, which is the length fallen off in a single second, will be the volume of water which has come out of the pipe in 1 second. Now after this, here we have just simplified this a little more, and then now, as it is the water which has come out in 1 second, to calculate the amount of water which has come out in 1 hour, so obviously we should multiply whatever we have on the right hand side with 60 into 60, because that much amount of time has now to be taken care of. So as such, 22 upon 7 into x, which is the length of water which has fallen off in a single second, is to be multiplied with this time, which is 3600. Now further children, the amount of water which got accumulated in an hour should match the amount of water, cuboidal shaped water, which has got accumulated in the cuboidal tank. As such, we will now equate both of these volumes, that is volume of water poured over an hour should be equal to volume of water accumulated, right? And thus now we have the values of both of these and we just equate them. So we have volume of water poured is 22 upon 7 into 7 into 7, 22 upon 7 into 7 into 7 into x into 3600, and on the right hand side we have the volume of the accumulated portion, which is cuboidal in shape and is in the cuboidal pond, is 15 to 100 into 44 into 100 and 21. So 15 to 100 into 44 into 100 into 21. Now we cancel off from both the sides. Now 22 cancels 44 two times, and then 7 cancels this 7 in the denominator. This 7 cancels off 21 three times, and then further we have 2 bars of 10 of 3600 getting cancelled with 2 bars of 10 from 100, and then further 3 cancels 36 12 times, and that is all. On the left hand side we are left out with x and 12, right, which in the next step can be brought to the denominator to make x the subject of the equation. And here on the right hand side we have 50 into 100, right, 2 remaining here, and then further this 100 has already got cancelled, and this 21 and 3 also have got cancelled. Now further here 2 cancels 12 6 times, and here further 2 cancel 6 3 times, and then 50 25 times. So we have 2500, which is divided by 3. Now we know that 3 8 is 24, 1 remainder, that becomes 10. So 3 3s is 9, 1 remainder 10. So that then again becomes 3 3s are 9, right? 1 remainder. So that becomes 833, 1 upon 3 centimeter per second, which is the length, rather first, which is the speed of the water which is required so that this amount of water, which is of height 21 centimeters, be accumulated in the cuboid shaped tank. Now children, 833 1 upon 3 centimeter is actually the length of water which should fall off from the pipe in a single second. So this is what was required in the question, that is to find out the speed of water which comes out of the pipe, and it has been done. So has everybody been able to understand this? Roma? Sure? Really? Yeah, that place was really lovely. So that was a place where you will get to feel nature. So this is something which I really liked about that place. Then that trekking, that skiing, that rink, all of those were really awesome things. So make sure when you get some time, you be to this awesome place. Bye children, have a nice time. Make sure you practice this sum, and you will get another sum in the description. Make sure you do that sum and take the pics of it and post it to me in my email ID, which is themathematicshelpline@gmail.com. Bye children, have a nice time. Bye.